Welcome back to the new video of this channel. So today we will be solving a problem which is Stone Game 2, lead code 1140 problem. So let's see the problem situation. So problem is saying that we have Alice and Bob continue their games with piles of stones. There are a number of piles arranged in a row and each pile has a positive integer number of stones, piles of I. So means piles of I is showing the stones. The objective of a game is to end with the most stones. Allies and Bob take turns and with allies starting first. Initially m equals to 0. So this statement is important. On each player turn, that player can take all the stones in the first x remaining piles, where x is the condition is given here. X is less than equals to 1 and greater than equals to, sorry, x is less than equals to 2m and greater than equals to 1. Then we set m equals to maximum of m comma x. So the game continues until the stones have been taken. Assuming Alice and Bob play optimally, return the maximum number of stones Alice can get. So to understand this statement is little bit tough because we have two conditions like here x have a condition like x should be greater than equals to 1 and less than equals to 2m, and also here m is here m पर भी condition लगी पड़ी है, ठीक है. So let's see this example. So we have given piles equals to 27944. So basically what we have to do, Alice and Bob both are playing optimally and we have to maximize the number of stones of Alice. So it means we have to minimize the number of stones of Bob, we can say this. So what we can do, the first is the thing is Alice is starting first. So initially m equals to 1. So if m equals to 1, so x can go up to 1 up to 2, because x can take value 1 and 2 because m equals to 1. So x should be less than equals to 1 and greater than equals to, sorry, x should be less than equals to 2 and greater than equals to 1. So m पर भी एक कंडीशन है, m equals to maximum of m comma x. if x equals to 1, so maximum क्या होगा, m equals to 1. if x equals to 2, तब maximum क्या होगा, m equals to 2. so ये चीज मेरे को दी हुई है. So let's open it and see how things are going on. So we have given this piles array. Now let's understand how we'll solve this problem. So if initially m equals to 1, so x can go up to 2. So and m equals to maximum of m comma x. So x can take value either 1 or 2. If x is taking value 1, it means we are taking the first stone. Alice is taking the first stone. So Alice ने पहला stone ले लिया, तो it means x equals to 1. So maximum क्या हो जाएगा, m equals to 1 था, so maximum क्या हो जाएगा, फाइनली m equals to 1 हो जाएगा, m equals to 1 हो गया. सो एंड सेकेंड स्टेप में क्या हो सकता है, या तो ये वाली वैल्यू ले सकता है कि x इक्वल टू 1 ले ले, या x इक्वल टू 2 भी ले सकता है. इफ अलाइस इज टेकिंग x इक्वल टू 2, इट मींस ही विल टेक 2 स्टोन्स. he or she will take 2 stones actually. if she is taking 2 stones, so 2,7 ये अलाइस के हो गए. it means x equals to 2, so m will be maximum of 1 comma 2, which is 2. so m equals to 2. now again m पर कंडीशन होगी, m कहाँ तक जा, x कहाँ तक जा सकता है, 2m तक जा सकता है. इट मींस x अब कहाँ से कहाँ तक जाएगा, 1 से लेके 4 तक जाएगा, ठीक है. सो इस वाली कंडीशन को बाद में देखेंगे. नाउ if x equals to 1, then m equals to 1, then again m equals to 1, so x can go up to 2. so अब मैं बॉब को देखता हूँ. if Alice is taking 2 only single stone, so Bob has two choices. Bob either can take 1 stone or 2 stone. if Bob is taking 1 stone, अगर बॉब एक स्टोन ले रहा है, ठीक है, बॉब इज टेकिंग 1 स्टोन. सो हियर बॉब इज टेकिंग 1 स्टोन. नाउ वी हैव चॉइसेस 9 4 4, ठीक है. एंड इफ बॉब इज टेकिंग 2 स्टोन्स, देन अलाइस ने तो एक लिया था, अब नाउ 7,9 बॉब ने ले लिया, ठीक है. अब भी मेरे पास 2 स्टोन्स बचे हुए हैं, ठीक है. अब नाउ 7 तक बॉब ने ले लिया. अब सेकंड स्टेप में क्या हुआ कि अलाइस के पास भी दो चॉइस हो सकती है, आइदर वो एक एक ले सकता है स्टोन और दो ले सकता है. इफ अलाइस इज टेकिंग 2 स्टोन, देन 9,4 अलाइस के हो जाएंगे एंड देन 4 बचा हुआ बॉब का हो जाएगा. इट हियर द सम ऑफ द बॉब इज 7 plus 4 which is 11, and the sum of Alice is 2 plus 9 plus 4 which is something 15. And if Alice is taking only one stone here, and Bob is taking 2 stones, 7,9, then remaining if Alice will take, then the sum of Alice will be 10 and sum of Bob will be 16. but I'll not take this because here bob count is maximum, but so in that case I'll not take this step. Now let's see this, but remaining stones are 3 because 2 comma 7 allies to ले लिया and remaining stones are 3 and Bob can take 3 stones because X can go up to 4, so Bob can take 3 stones. If Bob will take all 3 stones, then the sum will be 9 plus 4 plus 4, which is not less than the allies. So I'll not take this step because the sum of allies is 9 and sum of Bob will be after taking all the stock, sum of the Bob will be 9 plus 4 plus 4, which is 17, which is maximum, that maximum than the allies. So I'll not take this step, so इसको हटा देंगे step को. Now let's understand the recursive tree. So this is the example 2. This is the example 2. Let's understand it. So 1, 2, 3, 4, 5 and 100. So initially we have two choices because m equals to 1. So दो choices है, ठीक है. Either it can allies can take one stone or two stones. If he is taking one stone, then one stone allies पे गया, two stone किस पे गया, सॉरी, वन स्टोन अलाइस पे गया. एंड सेकंड केस में अगर अलाइस दो स्टोन ले रहा है, देन इन दैट केस टू स्टोन अलाइस पे गया. नाउ वी हैव अनदर चॉइसेस हियर x इक्वल्स टू 1, here x इक्वल्स टू 2. नाउ x इक्वल्स टू 2, so m, sorry, here x equals to 2, it should be m actually. Yeah, yeah, it should be a because x पर कंडीशन नहीं है, x एक स्टोन ले रहे हैं, यहाँ पे x 2 स्टोन ले रहे हैं, बट m भी यहाँ पे चेंज होगा बिकॉज m इक्वल्स टू मैक्सिमम ऑफ m कॉमा x. हियर x इक्वल्स टू 2 एंड m इक्वल्स टू 1, सो मैक्सिमम क्या हो गया, 2 हो गया, तो m इक्वल्स टू 2 हो गया. नाउ नाउ m इक्वल्स टू 2, सो x कैन टेक अप टू 4 वैल्यूज, सो 4 स्टोन से लेगा x. सो इट मीन्स, और टर्न किसकी है, बॉब की है, तो बॉब एक स्टोन ले लिया, फिर दो ले लिया, फिर ये 3 4 5 भी ले लेगा बॉब, फिर 3 4 5 और 100 भी लेगा. इट मीन्स अलाइस ने तो दो स्टोन लिए, which from is 1 plus 2 3, and Bob is taking all the stones, which is not optimal. Actually it is optimal, but it is greater than the allies sum, so she won't take this step because the sum of these all the elements of the Bob stones are greater than allies, so she will not take this step. And like this we can create a recursive tree. So after all this, we can find out the maximum sum that allies will take. So this is the approach. I have not created the whole recursive tree because it is much greater than, much bigger to create, because here m equals to 4, then m will be again 4, so it is bigger. So for understanding purpose it is enough. So now here what I will do, I'll take turn. If 0 means Ali's turn and 1 means Bob turn. So now let's create it. I am creating a function. Sorry, I have to return it because it's an integer value. So it returns solve of. I am taking files, comma. I am start. I am like turn. Initially Ali's turn. So I am showing Ali's turn with 0 and Bob turn with 1. And index will be 0 and m. M will be the m starting value of m is 1, so m equals to 1. So I will write here also. So 0 means Ali's turn and 1 means Bob turn. ठीक है. Now this thing is clear. Now what we will do? We will create a function like this, int solve. In solve function I am passing files, vector, comma int turn, comma int index, comma int m, because m भी change हो रहा है, ठीक है, according to m x will change. Now we'll write a base case. Base case will be something like if if I will declare the size here, if n equals to files dot size, then base case will be if I equals to n. अगर end तक पहुंच जाता है index, so in that case I can return simply 0. So this is the base case. Now what I will do, I will declare result. So let's declare it. Int result will be there, and according to that turn will change. So int result equals to, so let's understand with this example. If result equals to turn, I can take turn equals to 1. Now if turn equals to 1, so it means bob turn is there, बट बॉब टर्न को तो मेरे को क्या करना है, बॉब को तो मेरे को मिनिमाइज करना है. सो इन दैट केस आई कैन गिव हिम अ मैक्सिमम वैल्यू, बिकॉज if I want to minimize that value, so I initially I will give the maximum value. If bob turn, if alias turn is there, alias turn को क्या करना है, मेरे को मैक्सिमाइज करना है, तो I can give him a value initially -1. Now I will apply a loop. Before going applying the loop, I can initialize a size. Initially size equals to 0. Now I can apply a loop. Int x equals to 1 to x less than a minimum of 2 into m. 2m minimum क्या होगा, minimum 2m comma n minus I. So this can be a, this is a index n minus I, then I plus plus, sorry, x plus plus. Now I can add score plus equals to piles of what, piles of I plus x minus, sorry, I plus x. Now I have to decrease the 1 here, because we are starting from a zeroth index, so I have to decrease 1 here. So now we have score equals to piles of I plus x minus 1. Now we'll check a condition. If turn equals to 0. If turn equals to 0, it means it's a alias turn. So in that case, what will be the result? Result equals to score plus solve function, and in solve function I'll pass files. Now turn will be, if it is a alias turn, now turn will be bob turn, and index we will increase it I plus x, and now m will be something like maximum of m comma x, and in else case it will be same, but here some changes will be there. Score plus solve of I have, it will be 0, because if it's a bob turn, then now in again in next turn it will be alias turn, so it will be I plus x and maximum of m comma x, it is the same. After that I can simply return my score, or no, score is the result. So I think this is enough for this. Let's run and see if this will work or not. That is giving me something wrong. So let's see what is the problem here. Okay. So after that it is taking some values. Okay. So let's see what we have done here. Int score equals to this. If tan equals to this, then it will be something like yeah, things are going perfect. It should be minimum of 2m into tm comma n minus I plus x minus 1. It's perfect. Yeah, all things are perfect. So let's, so in that code we did a mistake. That mistake was, if alias turn is there, then we have to maximize that turn. So for maximizing that turn, we have to take a maximize step, and we have to add score here. We don't have to add score here, because if bob turn is there, we don't have to add score in that turn, because ultimately we have to maximize the alias turn. We don't need to add a score of bob turn, and we have to minimize the score of bob turn. So that's why we are taking max minimize here. So that was a mistake, and all things are perfect, and it should be inclusive, because x should go up to 1 to 2m into minimum of that particular 2m into n minus I, because it can take the values up to this. So that's why it should be inclusive. So now let's again run it and see is this will work or not. Yeah, you can see here it is working perfect. Now let's submit it. Yeah, it is giving me a TLE. Now let's see what can be the optimization for this. This solution was giving us TLE because it's a recursive solution, and that's why it is giving a TLE. So we have to optimize this solution. So and for optimization we can use memorization approach, but here memorization will happen in 3D way, because here I is changing, index is changing, m is also changing, and tan it also changes. So that's why we will use 3D to optimize this. So here's the solution of using 3D. We are creating a snapshot of we will initialize the DP with -1, and all things are same. And if it is Bob or it is Alice, we'll convert it according to that. And here we are giving uh, 0 means Bob, and 1 means Alice. So it means we are changing the positions according to that, and we are creating a mem set. It's not a mine solution. So I have taken this solution from others. So that's why if it is a Bob, then we have to, if it is a Bob, if it is a Bob, then we have to minimize that, and if it is a Alice, then we have to maximize that. Done. And all things are same. We are taking maximum. If it is above, then we will take minimum, and if it is a Alice, then we will take maximum, and after that we can return my DP here. So now if I run this, then it will work definitely. Let's submit also. Yeah, you can see it is working perfect because it's a 3D DP and it's a memorized solution. So no, there will be some optimization also. Now further optimization will be there. We can use top down approach, and further approaches will be there. So this is a good approach, and I will write it's not a solution. You can convert it. Actually, adding out the memorization, adding out the DP is very simple, because if you have a recursive solution, then you can add in the DP in. It's a very simple solution. What we have to do is we have to initialize a DP with -1, and we have to write this condition. And how we'll find out it's a 3D, because here turn is changing, index is changing, and m is also changing according to the condition. And here variables are changing, but you can use my variables. You can use this code simply. Actually this whole things will remain same, and after that we'll return DP. So it's a very simple to adding out the memorization. So this was the solution, and if you find this helpful, then please like, share, and subscribe. Bye.